Yeah, right. And in this class, I would like to teach you refraction of light, new chapter. There's a refraction, the phenomena of light. Other phenomena of light is a refraction of light. Okay, right. So in this class, I would like to teach you uh, the first one, the terms related to what is refraction, definition of refraction, definition of refraction, and the terms related to refraction of light, refraction of light, and next one, the characteristics of characteristics of refraction of light, refraction of light. Yeah, so I'm going to discuss these three topics in this class. And before that, what is the refraction and where can observe these refractions? For example, in the daily life here, and this is if you take glass of water. If you insert a pencil into the glass, now you can see that the pen. Whenever you pour the water into the glass, so it is appears. So from this point here, it is appears. It's like a bending. It's like a bending like that. So we have observed this type of example in our daily life. One more thing is here, and whenever, so this is a glass of water. Whenever you insert, for example, there is a coin is there, and at the bottom of the glass, whenever you pour the water into the glass, and this is always close. This is the position. So the size of the coin is increased, just like that, because of the refraction of light. So what is happening in that we are going to discuss. So what is the refraction of light? Refraction of light definition. Refraction of light. Refraction of light. Refraction of light. So refraction of light means the propagation of light. For example, if you take a one surface, this surface is not an opaque surface. If you want to observe refraction of light, definitely the surface should be a transparent surface. Transparent. That means the light should travel from one medium to other medium. For example, if you take this is the interface. This line is called as the interface. Interface means here is a it is a line where the total it separates the two mediums. For example, this is the air medium. This is air medium. From the air medium, light is coming like that, which fall on surface. After after interface, they're entering into other medium. For example, if we take water is other medium. Whenever the light is entering from the air to water, light gets bended. So this actually first draw the normal. This is normal here, and light is bends. Light is a bending. Light is bending, not going in this direction. So light always travel in straight line until the medium is changed. So here the medium is changed, and therefore light is bending like that. The bending of light from whenever the light is traveling from one medium to other medium, that is called as the refraction of light. So definition is the propagation of propagation of light, propagation of light from one medium to one medium to another medium, one medium to another medium, or when light travels from one medium to one medium to another medium, one medium to another medium, light, the light, the light, light is the light gets bended. The light gets bended. The bending of light is called as a refraction. Refraction of this phenomenon is called as a refraction of light. This is a definition of refraction of light. Just simply we can say that the light is to travel from one medium to other medium. Why it is bending? So what is the reason? What is the reason light always bending from when it is traveling from one medium to other medium? So because the reason is that here the velocity of light, the velocity of light, the velocity of light is different, in different medium. The velocity of light is different in different medium, different medium, different medium. That's why lights light is bending. Light is bending. Okay. Now here, so simply it is vacuum. So approximately the velocity of light, velocity, so velocity of light in vacuum or air. The velocity of light, velocity of light, velocity of light in vacuum or air, vacuum or vacuum or air. That is 3 into 10 power 8 meter per second. See the velocity of light. So velocity of light is maximum in air medium. Okay. If you see in liquids 2.25 into 10 power 8 meter per second. 2.825 into 10 power 8 meter per second. If you observe in solids, the velocity of light is 2 into 10 power 8 meter per second. Means here, if you compare, if you see here, velocity of light in air medium is more compared to the velocity of liquid and velocity of solids. That's why light is bending whenever it is traveling from one medium to other medium. Okay, next here. So now go for the some terminology. That is, for example, this is my surface interface where the light is entering. Okay. So here in this case here this is for example this is called as the air medium in which the velocity of the light is more. For example, I can take see the velocity of light is zero. So light is traveling in this direction, and this is a this ray is called as the incident ray. Incident incident ray. Okay. So at this point light is incident here and draw the normal here, normal, and light is bended like that. Light is bending like that. Okay. And here, so this is like a suppose I can take here. This is the water. Water is a medium. Water is a medium. So here the velocity of the light in water is v2. So in this case here, if velocity of light in the air medium is less than the velocity of greater sorry v1 is greater than v2. V1 is greater than v2. The v1 is the velocity of light in air medium. Velocity of light in a water medium. Okay, and actually this is called as the area is called as the optically rarer medium. So always this area is called as this medium is called as the optically 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 rarer medium means here the optical rarer medium velocity of light is more. What about water? Water is a optically denser medium, optically denser medium. So optically denser, this is the terminology very important here. Denser medium means the velocity of the light which is less than which is less very less value. Velocity of light is very less, and light in the is more. Okay, so this is very important here. What is the optical rare medium? So optical rare medium means here yeah, optically rarer medium. Optically rarer medium. Optically rarer mediums. It is a medium in which the speed of light is more. Okay. It is a medium in which the speed of light is more. 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 What about the optically denser medium? Optically denser medium. Optically denser medium. What is optically denser medium? So it is a medium in which speed of light is less. Speed of light. Speed of light is less. So these are the two mediums we need to remember. So rare medium means here. So always like in the next coming classes, I call rare medium and the denser medium. We should understand the rare medium velocity of light is more and denser medium is velocity of light is less. Okay, right. Next here, yeah, terminology or terms related to the refraction of light. The terms related to the terms related the terms related to refraction of light. Refraction of light. Refraction of light. The terms related to refraction of light. Okay. Yeah. Take this is the reference. This is the interface. This is the interface. This is the interface, and this is my incident ray. The ray which is towards surface, that is a incident ray. This ray is called as a incident ray. Incident ray. So here this is the point where light is incident. That point is called as a point of incidence. Point of incidence. Point of incidence. At this point, you can draw the normal. Normal means this is line is called as normal, which is always perpendicular, normal to the surface. This is a normal. This is a normal. Okay. After light entering from one medium to other medium, light is gets bended, and this is called as away from the surface interface. That is a refracted ray. So refracted ray. Okay. And this angle is called as a angle of incidence, and this angle is called as the angle of refracted. Angle of refracted. Okay. Just I write one by one here. The first is here incident ray. What is incident ray? Ray which is fall. So ray which is fall on the surface is called as incident ray. Next here, refracted ray. Refracted ray means the ray which is refracted. The ray which is refracted from the uh, interface, that is called refracted ray. Next here, third one, point of incidence. Point of incidence. Point of incidence. And this is the point where light is incident. That point is called the point of incidence. Next here, normal. So this is a normal line which is drawn at the point of incidence, which is normal to the surface. Next, fifth one, angle of incidence. What is the angle of incidence? Angle of incidence. So this is angle made by the incident ray with normal. Just here, figure. So this is the incident ray, is angle of incidence, and this is angle made by the incident ray with normal is called as the angle of incidence. And what is the refracted angle? Refracted means angle made by refracted ray with normal is called as a refracted angle. So refracted angle, that is a angle of refraction, angle of refraction or refracted angle. Refracted angle. So we need to remember this all terminology, because here, so most of the cases we use all terminology while we are studying the refraction of light. Okay, incident ray, we need to remember that here always light is fall on the surface, and refracted ray which is which is refracted from the interface. Okay, light is entering from red to and denser to there, whatever it is. But here light is entering refracted. So light is passing from one medium to other medium. The second medium ray is called as a refracted ray, point of incidence. This is the point where light is. So the light, for example, this is a surface, this is a light incident ray, this is the point of incidence. For example, one more ray I can take, this is a ray which is incident at this point, this point is called the point of incidence. What is normal? Just draw the normal at this point. This is the normal. This is a normal. At this, don't draw the normal for this instant ray. Always draw the normal for the surface only. Okay. Next, normal is over. Angle of incidence is over. Angle of refraction is over. Next, go for the characteristics of refraction of light. Characteristics of characteristics of refraction of light. Refraction of light. What are the characteristics? Whenever the light is entering from one medium to other medium, what are the characteristics of that refraction of light? Okay. The first one is, so when the light is traveling from rarer to denser, rarer to then first concept is here. If a light ray, if a light ray travels from light ray travels from travels from rarer to denser, rarer to denser, denser, what will happen? So here, for example, if you take the interface and this is a air is a rarer medium, this is a optically rarer medium, and water I can take. This is the water, other medium. So this is water medium is called as a denser medium, denser medium. Okay. So light is traveling from denser medium to rarer medium to denser medium, and draw the normal. This normal line always normal to the surface. This is normal to the surface here, and this angle is called as the angle of incidence, and this is the incident ray because it is towards the surface. Okay. So listen here. Here you know that here the velocity of light in the air medium is let us suppose v1 is the velocity of light in the air medium, and v2 is the velocity of rarer medium. So I can write here. See the velocity of light, velocity of velocity of light in a rarer medium, rarer medium, rarer medium, and v2 is the velocity of velocity of light, velocity of light in denser medium. So we know that here the velocity of light. For example, for example, one of the example I take and then explain here. For example, this is a road is there, normal road, plain road is there, and this is my car. Or otherwise, my bike is there. This is my bike here. This is my bike. Okay. So I'm going with a velocity of 120 kilometer per hour. 120 kilometer per hour. So unfortunately, there is a other road is there which is having the sand, which is having a lot of sand is there. When you're entering into this sand here, definitely direction of the bike changes and also velocity of the bike also changes. Means here the medium changes. This is a one type of road, other type of road. Similarly, this is a one medium, other medium. Definitely whenever you entering into medium, this medium is density is more. Density of medium is more compared to the density of air medium. That's why definitely velocity of light is decreased. So actually, if there is no medium here, light should go in this direction, but light is not going in this direction. So because that reason here, that refracted ray always moving towards normal. This is a refracted ray. So refracted ray. So first characteristic is here. Whenever the light traveling, light ray travels from rarer to denser, light refracted ray, the refracted ray, this is very very important here, we need to remember here. So refracted ray refracted ray bends towards normal, bends towards normal, bends towards normal. This point is very important. Whenever the light traveling from radiator to denser, the refracted ray bends towards normal. So this is the actual ray, and normal is one. So towards normal. This is called as the refracted angle. This is the first characteristic of a refracted ray. Okay. The second one, the second is a what is the second ray as a reverse here. Reverse means if a light ray, if light ray, if light ray travels from light ray travels from denser to rarer, denser to rarer. Reverse here. So your light is coming from the denser medium, rarer medium. This is what will happen. So here this is the interface, and this is a incident ray. This is the incident ray, and this is the point of results where we can draw the a normal. This is normal here. This is the angle of I. Okay, and this medium is a water medium. So water is this is water or denser medium. This is a denser medium. Denser medium. We know that here velocity of denser is here very small. So I can take this is a V1, and this is here air medium. Air medium. Okay. In that case here velocity of light in air medium is V2. Okay. This is a rarer medium. You know that here rarer medium velocity of light is more. Okay. Yes, this is a bit. If there is no medium here, definitely which is going in this path, no deviation. Okay. Yes, because of medium. So here the velocity of light. So here V1 is greater than V2. So V1 less than V2. Whenever the light is entering from denser to rarer, velocity of the here velocity is less. Velocity of light is less in the water medium, which is coming from actually initially water medium. The moment it entering into the rarer medium, velocity of light increase. That's why which is away from the normal. So always here, which is away from the normal, which is away from the normal. So this is the angle of refracted ray. It's very important here. So what is the very important conclusion point here? The conclusion point here, the refracted ray, the refracted ray, the refracted ray move moves away from normal, bends away from normal. So these 2 points are very important. Very to remember here. Okay, in that case here, angle of phi less than the angle of R. Angle of incidence less than the angle of R. In the previous case, angle of I greater than the angle of R. 2 points are very important. Like for next coming classes. Okay. Next point. Last characteristic, that is if a light ray travels from travels from travels from rarer to denser or denser to rarer rarer along the normal. In that case, so there is no deviation. So here, this is my interface. Light is exactly entering. For example, this is the air medium, and this is the denser, is the rarer medium. Rarer medium. This is the denser medium. So this is a instant ray exactly. So along the normal. So this is also normal here. No angle of incidence here. This is also normal. So there is no deviation. There is no deviation. This is also refracted ray. Okay. In the second case also, for example, this is a denser medium and this is a rarer medium. That is under denser medium to rarer medium and no deviation. So what is the conclusion here? The conclusion is that here no deviation along the path. There is no deviation for there is no deviation there is no deviation for refracted ray. There is no deviation for refracted ray. Refracted These are the three or characteristics of refraction of light. These are very, very important. Based on these characteristics here, we are going to study next coming classes. Okay, we need to keep all these points very, very important. The case of refraction of light. Okay, next most important here. Next one is here refractive index. Refractive index. What is the refractive index? Why the light is bending whenever the light is entering from one medium to other medium? Because here property of the medium. Because of property of the medium, due to which light get bends. Okay, na? More refractive index, more bending. Less refractive index and less bending. So that property of medium is called as a refractive index. Okay, I'll write the definition. It is a property of medium. It is a property of medium. It is a property of medium. Property of medium. Property of medium. Due to which light light is light gets bended. Light gets bended. Okay, this is the refractive index. In that year, in that first one here, first one is the absolute refractive index. Absolute refractive index. Absolute refractive index. Absolute refractive. What is absolute refractive index means here? Actually, which is represented by n. Okay, some textbooks they represent with it mu. Some textbooks measure with n. So mu or n. So I can take n here. Okay, that is absolute refractive index is equal to speed of light. Speed of light. Speed of light in vacuum. Speed of light in vacuum divided by speed of light. Speed of light in medium. Nah? That means here, so we compare the speed of the light in the medium with respect to the speed of vacuum. Okay, the speed of light in medium, it is always compared with the speed of light in vacuum. So this n is equal to speed of light is vacuum is c and speed of vacuum in the medium is v. That is n is equal to c by this is called as a refractive index. Okay, next one. Next here. Right. Okay, next here refractive, relative refractiveness. Relative refractive index. Relative refractive index. Relative refractive index. Okay. Here in the previous absolute refractive index means here light is always traveling from air to or vacuum to the medium, vacuum to the air to denser. Okay, the space vacuum to the medium. But in this case here, light is traveling from one medium to other medium. So this is the medium number one, and medium number two. So light is traveling from medium one to medium two. Okay, they are not compulsory from vacuum to the medium here. So they are always traveling from one medium to other medium. That is a relative refractive index here. That is n. N is equal to speed of light. Speed of light. Speed of light in medium one. Speed of light in medium one by speed of light in speed of light in medium two. Medium two. Okay, that is n is equal to speed of light in medium is v1. Let us suppose v1. Speed of light in medium time is n is equal to v1 by v2. Okay, this is the refractive index of the relative refractive index. Okay, so you know that here, and what is the speed of light in medium one with respect to the space means here, vacuum means here. You know that here, refractive index of first medium is n1 with respect to the vacuum. So c by v1. And what about refractive index of seconds? For example, refractive index first medium is 1, second medium is n2. Okay. What about n2 with respect to the velocity of light in a vacuum? So speed of light in vacuum by speed of light in second medium. Okay. We take ratio. We take ratio here. I want to write from this one v1 is equal to c by n1, and v2 is equal to bring this side and n1 is 1 c by n2. So take the ratio v1 by v2, v1 by v2. So c by n1 by c by n2, and take the reciprocal c by n1 and n2 by c get cancelled, therefore n2 by n1. So therefore from this one here I can write so refractive index of second medium with respect to first medium is equal to v1 by v2 or n2 by n1. So here light is traveling from first medium to second medium, but this indicates the refractive index second medium, refractive index of the second medium. So it is v2. The denominator value always indicate the refractive index of the second medium with respect to the first medium. Okay, so n21 is equal to n2 by n1. So refractive index of first medium with respect to first medium is, this is a formula for bit trimmer. So while doing problems, these problems are very important. This is about the relative refractive index and the what about the absolute refractive index. Okay. Now this we have seen for the plane surfaces. Now we go for the curved surfaces. Refraction through curved surface. Refraction through curved surface. Curved surface means we have two surfaces, concave and convex. We know that there. Okay. The first one here, light is traveling from rarer to denser at a convex surface. Otherwise, concave surface. A convex surface. Okay, convex surface. So this is my convex. Okay, this is the pole. This is the principal axis. This is the principal axis. Okay, and this is the total is here medium. I can take water medium. This surface is bulge surface. Bulge surface means here convex surface. Convex is convex surface. So this is a water. So it's denser medium. Denser medium. This is a rarer medium. Rarer. Light is traveling from, for example, we take one ray. This fall on this convex surface. Then you know that here what is the center of curvature? This is center of curvature. So very normal here. So normally just join the center point and the normal. Already you know the basics in the already studied in the previous class. This is a normal. So where is the refracted ray? So when light is traveling ray to denser, light bends towards normal. So but this is actual ray is going here, but they are bends towards normal. So that's why it is going like that. So this is the refracted ray. Okay. Let's see the point image formation. Okay. Right. This is about the light is traveling from red to denser. Okay. Next point. Next here, same surface, but light is traveling from denser to rarer at a convex surface. Convex surface. Convex surface. Convex surface. Okay. Yes. So you can take here. This is my yeah. This is a so now this is the water. This is denser medium. This is denser medium. This is the air medium. Rarer medium. rarer. No, light is coming from denser medium. So this is the principal axis. So this is principal axis. I can take a ray which is coming from the denser medium. Denser medium fall on the surface. So where is normal? This is the point center of curvature. This is normal. This is a normal. So this actual ray going like that. But another light is traveling from rarer to denser, which is refracted ray, which is always away from normal. So away from normal means it's going like that. This is a refracted ray. Okay. These are two observations we made, and whenever the light fall on curved surface, the convex surface. Next one more here, third one. So light ray, which is coming from traveling from rarer to denser at a concave mirror. Sorry, not a mirror, convex surface. So this is a concave surface, that is a refracting surface. Not reflecting surface, refracted surface. Okay. Yes. In that case, here I can take concave surface. This is a concave surface. Okay. So convex is a refracting surface. So this is a light ray, and I first draw the principal axis. And this is a pole. This is center of curvature. Okay. So light is fall on the surface, and first draw the normal at this point. This is normal here. We know that here, and whenever the light is traveling from rarer to denser, the reflected ray always bends towards normal. So bends towards normal means, so always this is normal here. This is going, so this is a refracted light. This is a refracted light. Okay. Next, last one. So light is travels from denser to rarer at a concave surface. Concave surface. Concave surface. Right. So I can take here concave surface. It's the water. Denser medium. This is denser medium. Principal axis. Okay. Yeah. That is traveling from denser medium to rarer medium, and draw the normal here. This is center point, center of curvature, and this is the normal here. Normal. You know that here light is whenever the light traveling from denser to rarer, light bends away from the normal. So away from normal means this is normal here. This is actual ray. Away from normal means here. So this is going like that. So going like that. So this is the observations we make. Okay. This is the refraction through curved surfaces. Now in the previous next class, so we are going to make a relation between the um, object distance and the image distance and the refractive index. Refractive index the first medium, refractive index the second medium. We need to make the relation. So then after we'll go for the lenses. Okay.